All right, class. This is a review for the quiz that is this week for quiz 3.4 through 3.7. So basically, there's six questions on your test. There's like 15 on this. All right. I even included on the back end of this the answers as best as I could give them. And so you can kind of check. But I will do each problem briskly so this isn't too long. First of all, when it says graph each equation, you have to be given the equation, like in this case, the absolute value, this. You have to recognize, hey, that's an absolute value, and your mind should instantly go to what the graph should look like, which is a V, right? And the key is to find where the tip of that V is, the vertex. So the parent function is a V that's centered on the origin. So the parent function would, that's not what I needed, would be this. That's the parent function. And notice the slope of the parent function is 1. So what we're going to do is look at the equation that they gave us. That's the absolute value. So it's this right here, this dashed line. But it's shifted to the right. Remember, if the number's holding hands with the variable, it's going to do the opposite of what it looks like it's saying. Because when you look at x minus 1, you're thinking it's going to the left to -1, right there. But that's not true. I used to say your x's are liars, but when we're talking about equations of circles, when there's a number on the y, adding or subtracting, you got to do the opposite there too. So it's basically when the number's holding hands, and holding hands means it's either minus or plus, it's going to do the opposite of what it says. So -1, instead of going to -1 on the x-axis, it's going to go to +1. It moves it to the right one. So the transformed graph would be this. Okay. And so that's the transformed graph. It says domain and range. Well, for absolute values, domain is all real numbers. And the range is going to be restricted. Y is greater than or equal to 0. Because remember, range is the Y values, the outputs. So we kind of go up and we scan, we see, hey, the graph begins right there. Well, what's the Y value right there? That's 0. And then the graph is above it. So Y is greater than or equal to 0. So that's question number 1. Question number 2, it's going to be the parent graph. Okay, here's the parent graph right there. And it's shifted to the right 4 and down 2. So right 4 and down 2. All right? But now you have to take into account the fact that the graph is negative right there. So the graph is sad. Instead of smiling at you, because remember, this is a smile, it's happy. It's happy. Instead of smiling at you, it's going to be frowning at you. So this graph is going to get changed. Instead of opening up, it's going to open down. So the transformed graph would be right here. But we go to the right 1, down 1. Has a slope of -1. and a slope of positive 1 to the left. All right, so there is the graph of this function, number 2. Notice the domain is still all reals. It doesn't change for the absolute value. And for the quadratic too, all real numbers, all reals, all real numbers. It's going to bug me that there's an S on that. Okay, the range, again, it's the y values. Notice, if we go up, we see, hey, the graph is all down here. So let's go from the top down. We see the graph begins right here at -2. Not only that, the graph is then below -2. So that means the range is going to be all y less than or equal to -2. All right? And there you go. And you could also describe this, number 1, it's shifted right 1 unit. Number 2 is shifted right 4 units. Okay, and down 2 units, and also it's reflected around the x-axis. Okay, write the equation for the function shown. So now they give you a graph. On these questions, you're going to have to look at the graph and recognize that. Is that a square root graph? Is it an absolute value graph? Is it a quadratic graph? In this case, I hope you recognize that this is an absolute value. It's a V. Not only that, it's a V that opens up. So it's not going to be reflected. So you could say f of x is going to equal the absolute value. Now we're shifted to the left 2. So it'll be x plus 2. Remember, when it holds hands with the x, it does the opposite. And it's down 3. So it's -3. Now we're almost home. The only thing is, is this graph being stretched from the original parent graph? Or compressed? So let's see. The normal graph will be up 1 over 1. Up 1 over 1. Up 1 over 1. Obviously, it's not up 1 over 1. It's up 1 over 1, 2. So there's a 1/2 in front because this is the slope. M is 1/2. And you get that from counting. Again, I chose the vertex and I saw that I had to go over 1, 2, and up 1. Over 1, 2, and whoa. Over 1, 2, up 1. Over 1, 2, 3, up 1. Over. Oh, I'm going off the white. I better go off the. Sorry. I was like, what's going on? No. So you see, go over 1, 2, 3, up 1, 2. So actually, my slope was wrong because I was counting it off incorrectly. It's going to be 2/3, up 2 to the right 3. All right. Now, on number 4, you have to recognize that's a quadratic. So you know your parent graph is going to function as f of x equals x squared. Now we have to see how it's moved. Well, it's moved, if you look at this, it's moved to the right 1, 2, 3, 4, and up 1, 2, 3, 4. So it's moved to the right 4 and up 4. So the transformed graph will be f of x equals, it's going to be to the right 4 squared, and up 4. Okay, now we have to figure out, well, we know it's going to be a negative sign because the graph is sad. Remember, the negative sign reflects it across the x-axis, which makes the normal happy graph sad. And then we have to see if it's just, if the number in front's 1. So the way we do this, the normal pattern is you go over 1, 1 squared is 1, we should go down 1, but we don't. It looks like we go over 1, 2, and we go down 1, 2. All right? So over 2, down 2. So over 2 is 2 squared. That would have been 4, so we have to divide by 1/2. So there's a 1/2. Because now, once we wrote this, we can check. We see that the graph is at 4, 4, which is right there, and then we go over 1, 2. 2 squared is 4, multiply by 1/2, we go down 2. We go over 1, 2, 3, 4. 4 squared is 16. Multiplied by 1/2, we go down 1, 2, 3, 4, 5, 6, 7, 8. So it matches. And there's the equation. Now, on 5, both 5 and 6 and 7 and 8 are pretty much the same thing. It's a square root graph. So on 5, it says describe the transformation of the parent function, graph the function, what is the domain and range of the function. So looking at this is a square root graph shifted to the left 5 and up 5. So that's the beginning. You also should recognize, hey, this is a square root, so you do that. It looks like a little kind of swish. Now, the trick was to find the starting point. So it's right there. Now, the negative sign means instead of going up, we're going to go down. So before, the pattern would be, if it was just a regular square root, we go over 1, 1 squared is 1, and we go up 1. Sorry, square root of 1 is 1, and we go up 1. Over 1, 2, 3, 4, the square root of 4 is 2, and we go up 2. We go over 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3, and we go up 3. That's how you would do it. And then you would make the swish. So you can kind of see the tips, right? You would connect the tips. So it would be like that. But here's the deal. It's a negative 3. So instead of going over to the right 1 and up 3, we're going to go to the right 1, square root of 1 is 1, and we will go down 1 times 3. So over 1, down 1, 2, 3. So here's the next point in the graph. We're stretching it. So we go to the right. 1, 2, 3, 4. Square root of 4 is 2. Multiplied by 3, we go down 6. So we're down here. Okay. 1, 2, 3, 4. Square root of 4 is 2 times a negative 3. So this is 2 times a negative 3 is negative 6. And we count from here, right? We go 1, 2, 3, 4, 5, 6. We go over from this point 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. Times 3 means we go down 9. So we go down, that's 5, 6, 7, 8, 9. So it would be here, I think. I hope I count right. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3 times a negative 3 is negative 9. We go down 1, 2, 3, 4, 5, 6, 7, 0.89. Actually, it's right here. And the graph would be like that. It says graph the function, describe the transformation, shifted left 5, and up 5, reflected, that's the negative sign making it go down, about the x, and stretched by a factor of 3. The domain it's restricted. It's all x greater than or equal to -5. The range, which is the y values, is again restricted. Okay. It starts here at +5 and the graph is below it. So y is less than or equal to 5. And there you go. Okay. Question 6. It's a square root graph shifted to the right 4 and up 2. So the starting point is right 4 and up 2. It's right there. Now, the graph is multiplied by a half. I'm going to have to stop this and start over in a moment.